All right, so we are now going to talk about graphing proportional relationships when two quantities x and y are proportional. The relationship can be represented by the direct variation equation. That's y equals mx. Very similar to the slope-intercept form, but we're not talking about b. Where m is the constant of proportionality. So this information below is not on your paper, but I did write it on here and I put it on mine for extra notes. So the constant proportionality is the unit rate, which is the slope, and the slope is represented with m. So the other thing that's written on the board that is not on your paper that I suggest you writing in is this little graph. So a constant of proportionality has to cover two things. First, it must be a straight line, so a linear equation. And second, it has to pass through the origin 0, 0. So those are the two requirements that it has to have. All right, so example 1, graphing a proportional relationship. The cost y in dollars for x gigabytes of data on an internet plan is represented by y equals 10x. So we're going to graph the equation and interpret the slope. So we have y equals 10x. I'm going to make a table of values. We have gigabytes, which is going to be our x values. And then we have the cost, which is our y. All right, so 0 gigabytes is going to cost us $10. 1 gigabyte is going to cost us, 0 gigabytes, I'm sorry. 0 gigabytes costs us $0. 1 gigabyte costs us $10. Let's skip to 5 gigabytes. That's going to give us the cost of $50. 7 gigabytes is going to cost us $70. And let's end with 9 gigabytes. That's going to cost us $90. We're not talking about unlimited plans. I know some people have brought that up before. All right, so now we need to graph this. So my x values is gigabytes, so I need to label it down here. Gigabytes. And then my y value is our cost. All right, and that's going to be in dollars. Okay, so I'm going to label this. Every one of these is going to be 1, so I'm going to label every other 2, 4, 6, 8, 10. And then we know that it's going to be increasing by 10 every time. So this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm actually going to go back and I'm going to get rid of my 10 and my 30 just because then it doesn't have as much information and it's not as confusing. So we're going to start at 0, 0. So this does have a constant of proportionality because it passes through the origin 0, 0. Then I'm going to plot 110, then 550. Then I'm going to go to 770 and 990. And I'm going to draw my line through those points. And I'm going to label this y equals 10x. The last part it says is to interpret the slope. This is really important that a lot of students wind up forgetting is to interpret it. Saying that the slope is 10, that's not enough. It's great that you know the slope is 10, but we need to interpret what it means in the real world. So, the slope means for every 1 gigabyte of data used, It costs $10. Let me fix my dollar sign. So that's interpreting the slope, explaining what that slope actually means. All right, I'm gonna get the board up for example number 2, writing and using a direct variation equation. So the weight y of an object on Titan, which is one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So letter B, write an equation that represents the situation. So we're going to start with y equals mx. All right, so this y is going to be the weight on Titan. It says up here, the weight y of an object on Titan. Weight y of an object on Titan. And then is proportional to the weight x of the object on Earth. So y is the weight on Titan, and x is the weight on Earth. So if it's 105 pounds on Earth, it's 15 pounds on Titan. I'm going to plug that in. 15 equals m times 105. So the opposite of multiplying by 105, and you know what, let me get rid of the parentheses, let me use the multiplication dot. I'm going to divide both sides by 105, and I get that the slope equals 3 divided by 21, which reduces down to 1/7. So that means y equals 1/7 x. So there's my equation. So how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Well, we know that the 3.5 equals y. So that is plugged in. 3 5/10 equals equals 1/7 x. I want to isolate my x, so I'm going to multiply both sides by the reciprocal, which is 7 divided by 1. And I get that x equals 24 and 5/10. So to interpret what that actually means, that is 24 and 5/10 pounds, which are also lbs. That's another way to write pounds. Okay, so example 3, comparing proportional relationships. The distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation y equals 2 and 5/10 x. The graph shows the distance that a 2-person lift travels. Which ski lift is faster? All right, so we have a graph and we have an equation. We're going to need to figure out either the slope of the graph, or we would need to graph the 4-person ski lift. So what I'm actually going to do is I'm going to figure out the slope of the 2-person lift. So for our 2-person lift, I'm going to use my slope formula of y2. So slope equals y2 minus y1 divided by x2 minus x1. So that's going to be 12 minus 4 divided by 6 minus 2. 8 divided by 4, which equals 2. So that means our equation y equals 2x. Well, if I go back to my 4-person lift and write down the equation y equals 2.5x, I can go ahead and now focus on my slopes. 2 5/10, 2. Well, the graph that represents the 4-person lift, that one's going to be steeper because you're going 2 5/10 miles per hour, or I'm sorry, not miles per hour, meters per second versus 2 meters per second. So the graph that represents the 4-person lift is steeper. Therefore, it is faster. All right, so we're gonna go ahead. Ooh, did I skip to the next problem? Nope, nope. All right, so we'll move on to letter E. Whoops. All right, so graph the equation that represents the 4-person lift in the same coordinate plane as the 2-person lift and compare the steepness of the graphs. What does this mean in the context of the problem? All right, so we already know that the 2-person lift is going to be at 2, 4, and then at 6, 12. You start at 0, 0. So this is the 2-person. So then for the 4-person, we're going to start at 0, 0. We're going to go up to, let's go 2, 5. So here's 2 up to 5. Then we want to go 4 to 10. I'm going to connect these. And this is going to be the 4-person. So I use different colors to represent each of them. It makes it a little bit easier to read. So then if we look at and compare the two graphs, which one, compare the steepness of the graph. So the 4-person lift is steeper than the 2-person. What does this mean in the context of the problem? This means that the 4-person lift is faster. Which we had established in the previous problem as well, but this is just to visualize it now. All right, letter F on your own. Feel free to pause, then come back. The table shows the distance y in meters that a T-bar ski lift travels in X seconds. Compare its speed to the ski lift in example 3. So a T-bar ski lift is one that you wrap your legs around and it just kind of pulls you up rather than one that you sit down or one you climb into. All right, so here's our table. After 1 second, it goes 2 1/4 meters, 2 seconds, 4 1/2, 3, 6 3/4, and after 4 seconds, it's gone 9 meters. So let's go with y equals 2 1/4 x. Because that's how many meters per second. That's our unit rate. That's our constant of proportionality. That's going to be our slope, 2 1/4. I like dealing with decimals personally more, so I'm going to convert that y equals 2 25/100 x. No, you don't have to write it that way, but I prefer it. All right, so if we look at our previous equations, we know that the 4-person lift is, so 4-person was y equals 2 5/10 x. The 2-person, y equals 2x. So if we compare the ski lifts from example 3, well, it's not as fast as the 4-person, but it's not as slow as the 2-person. So the T-bar lift speed of 2 25/100 meters per second, so MPS is meters per second, is faster than the 2-person lift, but slower than the 4-person lift. All right, excellent job.